Okay, here you go. Depending on what you've heard in class or didn't hear in class, this is my explanation of how to do chemical nomenclature going from formula to name. So this means I'm giving you the formula of the compound and I'm asking you to write the name. Alright, so we talked about three different questions. You have the first question here, is there a metal in the compound? I think that's probably the most important place to start with this, identifying whether or not there's a metal in the compound. And if you're looking for a metal, you're looking for the first part, the left half of the compound. We'll be able to tell there. If there's a metal, then you need to decide, is it a transition or is it a heavy metal? And we have two different types. We have a type 1 and we have a type 2. And we talked about that on our periodic table. If there is no metal, we need to decide whether or not there's hydrogen in the compound. If you have hydrogen, then what you have is an acid, and if there's no hydrogen, then what you're doing is naming a covalent binary compound. So let's walk through this. Let's assume we see a metal. We see that the metal is not a transition or heavy metal. And then what I'm asking you is to count the different elements. If there's only two elements, what you have is an ionic binary compound. And the rules for naming that are very simple. You write the name of the metal first, and then you write the name of the nonmetal. And you're going to change the ending. You're going to drop the element ending and add IDE. So instead of saying, for example, NaCl, sodium chlorine, we will drop the ene and add IDE, sodium chloride. If there are three or more elements, what you have then is an ionic ternary. And again, you're going to write the name of the metal first, or the cation, and then you write the name of the polyatomic ion second. There's another version of this if the polyatomic ion is a cation, and we'll cover that probably in class. What if the transition or heavy metal, you see that? Well, again, you're going to count the different elements. If there's just two elements, if it's a type 2 metal and a nonmetal, you're going to write the name of the transition metal first, and then you need to determine the charge on the metal. And we do that by using the nonmetal. The nonmetal is the one that's going to have the fixed charge. And so I look at the formula and decide what the charge of the transition or heavy metal is, and that gets written as a Roman numeral in parentheses after the name of the element. And then I write the name of the nonmetal second, changing its ending to IDE. And we'll go through an example of that when we're done here. If I see three or more elements, again, I'm thinking polyatomic ion. And I have to figure out what the charge in the transition metal is. And I'm going to put that as a Roman numeral after the name of the metal. And then I write the name of the polyatomic ion second. Pretty simple. If we don't see a metal, then you're going to go this way, and I need to decide whether or not the first element is hydrogen. If it is, there are two different types of metals. We can have a binary acid, and if I just see hydrogen and a nonmetal, then I write the name is hydro, then the root name here, and then I put an ending of ic and acid. So if I was thinking of HCl, that's hydrogen and chlorine, it would be hydrochloric acid. If I had H2S, hydrogen and sulfur, it would be hydrosulfuric acid. So we'll practice those. If there's a polyatomic ion, I need to look at what the name of the polyatomic ion is. If it ends with ATE, if it's sulfate, then it would be sulfuric acid. If it's nitrate, NO3, it would be nitric acid. If the polyatomic ion the name ends in ITE, then the acid is an OUS acid. So if I was looking at nitrite, it would be nitrous acid. If I was looking at bromite, it would be bromous acid. Those are the rules for naming acids. If hydrogen is not the first element, count the number of elements. If there's only one element, then makes it a diatomic element. And these are the 7 different diatomic elements. I learned these, we had to memorize them, and I just made up mnemonic in my head that chemistry is not fun, only boring. Ha! But you could probably come up with something that's not quite as lame as that. If there are 2 elements, what we have is a covalent binary compound. And we use Greek prefixes to name those. The mono, di, tri, tetra, penta, hexa. And so you're going to name the first element, and if there's more than one of it, you're going to put a di or a tri. Let's say if you had 2 of them, it would be di nitrogen. And then you look at the second element, and again, the subscript tells you how many you have of it, and I am going to use that Greek prefix. One that you're probably very familiar with is carbon dioxide. Carbon and oxygen are both nonmetals. Dioxide means 2 oxygens, CO2. And again, we end it by using an IDE. So that's this flowchart should be very helpful for you. So again, is there a metal? Is the metal heavy or transition? Is hydrogen the first element listed? If you look at the first one here, carbon and oxygen are both, there's no metal. So I go down to this one, is hydrogen the first element? No. So I'm going to be using Greek prefixes. And here I don't see, is there a metal? No. Is hydrogen the first element listed? Yes. So I'm looking at an acid. Here, magnesium is a metal. Is it heavy or transition? No. Well, it's a type 1 compound then. CsBrO3, CS is a metal. And it is group 1, so it's a type 1 metal also. But this is a polyatomic ion, so this would be an ionic ternary type 1. HBr, there's no metal. Hydrogen is the first element. This is a binary acid. Chromium nitrate. Well, chromium is a metal, and it's a heavy metal or a transition. So this is going to need to have Roman numerals after the name chromium. You need to figure out what the charge is. Gold sulfide. Well, gold is the same thing. It's a metal and it's a transition metal. So it's again going to have Roman numerals. O2 is not a metal and it has just one element. So the name of this is going to be just the name of the element, oxygen. How's that sound? Better?